Be talking about the Titan submersible implosion. So what was the Titan disaster? The Titan was OceanGate's commercial submersible designed to reach the Titanic, and on its 13th journey down on June 18th, it never came back up. The founder of OceanGate was Stockton Rush, and on board the Titan, there was Stockton Rush, Hamish Harding, who was the president of Action Aviation, a British Pakistani businessman, Shahada Dawood, and his 19-year-old son, who did not want to go on this journey because he was scared, but did because it was Father's Day. And then the last person on was P.H. Nargolet, who was a Titanic expert and diver. And the force of this implosion would have been so violent that everyone on board would have died before the water touched their bodies, so they wouldn't have felt it, which is good. And then before this, no manned deep sea submersible had ever imploded. So let's go through the final steps of the Titan's final journey. So at 8 a.m. that Sunday, it submerged under the water. And then an hour and 45 minutes later, it lost contact with the Polar Prince, which was the boat that towed it to its location. And then it also dropped the weights, which indicated that they were trying to abandon their mission because something bad had happened. And then it was supposed to resurface at 3 p.m. that day, and it never came up. And then at 5:40 p.m., the Coast Guard was notified that something was wrong and the vessel never came back. And then later, acoustic data found an anomaly consistent with an implosion when the communication was lost. And then, however, after that, sonar equipment detected banging noises Tuesday night and Wednesday morning. So some people thought that the Titan was still out there and the people were still alive. And then Thursday at 6 a.m., that was when the air was supposed to run out on the Titan. So that means the people would definitely be dead. And then later that morning, the tail cone, front and back ends of the hull were found, and they figured out that the Titan had imploded and everyone was dead on board. So just to start off, the differences between a submersible and a submarine. So the Titan was a submersible, and submersibles are manned. They only go down for a few hours, and they need a mothership to get them to their location in the ocean. And then a submarine is usually autonomous, and it has enough power to go down for weeks or months, and it can leave from a port itself, so it doesn't need a mothership or any boat to tow it anywhere. And then just to go over what an implosion is, there's a quick video here to watch. So this kind of just shows that was how fast the Titan would have imploded, and that shows how the Titan probably imploded. And an implosion is just fast inward traveling water surrounding by receding walls of a structure when it breaks under the pressure. And then it's the net pressure differential across the walls is what causes the collapse. So yeah, that's pretty much what happened with the Titan. And then at the depth of the Titanic, water is 4% compressed. So that means, and water is not really a compressible fluid. So when it is compressed and it got exposed to the 1 atmosphere chamber, it would be like releasing a spring with high explosive force that was similar to the speed of sound. So you can just imagine like how dangerous that force would be. And yeah. Let's put Okay. And then they also did a study on the implosions of a thin-walled cylinder, and this was a metal cylinder, and you can see the setup in this picture. So it had a 54-inch internal diameter. It was 102 inches in length. The pressure capacity was 1440 psi, and they used a high-speed camera to capture all the data. And the length over distance they did, or the sample that they did, the L over D, so the length over the diameter was 2.0, and the length over the diameter of the Titan was 1.72. So then in this result, you can see that it imploded at a mode 4 collapse of 676 psi. So you can see here on the metal structure, it kind of just all got collapsed inward. And then in the column photos, you can see kind of step by step how the implosion happened. So then after this, they repeated that same study in a simulation and found the exact same thing. So that kind of told them that their experimental setup was correct, and it pretty much verified the data. So yeah, that's just pretty much what an implosion is. And then a successful submersible that happened was the Alvin, and it was actually able to successfully travel to up to 6,452 meters. And a reason it is so successful is because it has a lot of routine inspections. It's always being recertified, and the Navy is auditing it a lot. It's also disassembled, evaluated, and reassembled every few years. So just to make sure everything's good. And then at this point now, at the 6,400 feet or meters, it can access 99% of the ocean floor, so pretty much the entire ocean. And it also has a lot of redundancy, so if there's a failure, there's something else to back it up so it won't completely fail. And then they call off dives if there's any suspicion. And one instance of that was they found that they got new windows in one of the iterations of the Alvin, and they were looking over and they noticed a little like nick in the window, and instead of like continuing with that, they called off the dive and re-evaluated it and realized that could have caused an issue. So they were just really strict about not going on dives if there's a problem, which you'll see the Titan was not doing that at all. And then their order of priorities on board was first safety of the crew, then safety of the vessel, and then the mission. So the safety was always more important than the mission, which is actually the opposite of how the Titan was operated. And then it's had over 5,000 successful dives. So moving on to the differences between the Titan and the Alvin, there's a lot of key differences. The Alvin, first of all, had a spherical hull, while the Titan had a cylindrical hull. The Alvin only could hold up to 3 passengers, while the Titan held 5 passengers, so it was a lot larger of a hull. And then the Alvin was made out of titanium, and the Titan was made out of carbon fiber, which we're going to go into later about why that's bad. And then the Alvin had a mothership, so it didn't get towed. It was literally on top of the ship, and then it got put into the ocean, whereas Titan was towed behind the boat, and that could have caused extra damage to the submersible. And then the Alvin had multiple small windows throughout its body, and then the Titan had just one large window. So there's 4 key reasons that I think it imploded. The main being because of the hull, which was made of carbon fiber, and its shape. Also, I think the viewport was just a bad design, and the same with the whole warning system. And then overall, it was just not a clean sheeted design, which is never a good idea for any engineering thing you're going to make. So moving on to the carbon fiber hull. So there's been reports of people that went on successful journeys of the Titan that they said they could hear cracking during the entire journey, and it was just they could hear it, and that's pretty scary. So the reason that the OceanGate even wanted to use a composite is because there is some benefits of using a composite for ocean journeys. First off, it's much lighter than titanium, and it's 3 times better on strength to buoyancy than titanium. And then it also has better corrosion resistance because the seawater is a very corrosive environment. So, and composites don't corrode as fast. And then composites also have low thermal, acoustic, and magnetic signatures. So this is kind of the assembly of the Titan as a whole. As you can see, there's 2 end caps with the carbon fiber hull, which is in the middle. And then you can't see in the picture, but there are rings or titanium rings on the sides, kind of adding structure to the hull. So the carbon fiber wrapping, here's an image of kind of or a video of how it was made. You can see it was kind of wrapped around the hull only in one, it was unidirectional, which is really bad because it means it's only going to be strong in the one direction of the wrapping. And then it ended up after this being 5 inches thick and had 667 layers. And you can see here there's air bubbles on the wrapping, which could cause little imperfections, which would not be good in the long term for the strength of this. So then, and then another issue was for the adhesion of how they put together the carbon fiber hull and the structural titanium rings. So glue was the only way they joined the 2 rings. Here, I'll play this video too. That's kind of showing it.
The 2 components, really what's holding them together and allowing them to move together is the glue. And so you want nice, even movement.
And then you can see
The
here
glue
they were
just
just dropping it
You want to
down
make sure it's right.
into the hole, and they're working on it in the back
It's
there.
pretty simple, but if we mess it up, there's not a lot of recovery.
Okay, so just to kind of expand on that video, the glue was the only method of joinery between the carbon and titanium, so they didn't use any bolts or anything as a secondary method. If you saw in the video, they were just cleaning it with a rag, but then his hand was following behind it, kind of getting it dirty again and adding oils. And when you're doing adhesives, you don't want anything on the surface, so they definitely could have done a better job cleaning it. And it was also not bonded in a clean room, which would have been in a better environment to ensure the bond was good. And again, no humidity or temperature control or clean room. And then the glue was hand mixed to this to the adhesive, so there could have been air bubbles, and also there's no glue of commercial off the shelves that are proven to work for this kind of a bond they wanted to make, so that means they had to improvise and do their own glue. So there's no way to know if that glue would work, especially because they didn't do any testing. And then if you saw in the video also, the titanium rings were very smooth, and usually with adhesives you want to add a rough surface because that kind of increases the surface area and it makes it easier to like use or to connect the two, and it makes the bond stronger. And then in the video, when the carbon fiber hole was, or the ring was dropped, the titanium ring was dropped into the hole, no glue squeezed out, so it's possible they didn't use enough glue, because you'd if it was good surface contact, you would expect some glue to squeeze out. And then it also wasn't press fit in, it was just dropped right in. And also if it was press fit, glue would have came out. So, and I already mentioned the not off the shelf adhesive. And then carbon fiber this is a big one, 5 times more compressible than titanium. And since their compressibility is stronger or different, under all the pressure, they could have pushed and pulled apart differently. They wouldn't have expanded or contracted together. So the adhesive would be put under a lot of stress under all the compression that was going on.
Check measurements.
And then, okay, now moving on to the shape of the hole. Again, we can see the Alboven had a very spherical hole, which you can see in the picture right here. And then the Titan had a very cylindrical hole. And in a cylindrical hole, the pressure is unequally distributed between the body, so it could cause it to kind of crush like a soda can, which is why typically all holes that are in submersibles are spherical. So then just kind of to relate this to airplanes, of why in the air a spherical hole is better than a cylindrical hole, is because in a spherical stress matrix the highest stress is PR/2T, and then in a cylindrical stress matrix it's PR/T, so 2 times higher. And this isn't the exact relationship for submersibles because all of the data is really experimental still, and there's no like closed solution for the stress matrix of of submersibles, but it would be a similar relationship in that the sphere would be a lot stronger than the cylinder because of the pressure being a lot more balanced. So then also here you can see in an airplane, that's why carbon fiber works, because in the pressure in an airplane, it's in tensile stress because the material or the air inside wants to expand, so it's kind of pulling the carbon fibers apart. But then in a submersible, the pressure is coming in, so the carbon fiber is actually in tension or compression, and it's really not strong in compression. So you can see here in this video, they're testing the tensile strength of carbon fiber, and you can see it lasts a really long time and it's really strong in tension. So that's why it works in an airplane. And then later we're going to have a video on carbon fiber in compression. Okay, so here is the compressive strength of titanium versus carbon fiber. So you can see from the video that the carbon fiber is going to fail a lot quicker than the titanium. So that the carbon fiber already saw failure at around 2000, whereas the titanium is already at 6,000 and it's still going strong. So yeah, you can just see that's kind of how the carbon fiber compresses, and it just buckles a lot, whereas the titanium stays a lot stronger. Okay, so why carbon fiber does not work for deep sea compression or deep sea applications. As you saw in the previous slide, the fibers are in compression, and carbon fiber is not strong in compression compared to its tensile strength. And carbon fiber is really only strong in the directions of the fibers, and the fibers were wrapped only unidirectionally, which means they would only be strong in one direction, which under any unstable loading, the carbon fiber would just not be strong at all. And the strength in the other directions of the fiber are just pretty much equivalent to the strength of the adhesive, which is not good or not as strong as it should be. And then the compression causes the buckling. So obviously when it's under compression, it causes the individual fibers to buckle and break. And then the cracks are also very hard to see because they're usually embedded in between the layers, so you won't be able to do from a visual inspection see the cracks. And then Carbon fiber also gets weaker every time it goes to high pressures, whereas titanium, it's kind of being cold worked and compressed, so it's not necessarily getting weaker with every journey. It can actually get stronger. And then carbon fiber is like just very brittle in compression, so buckling and cracks will make it not airtight, which would cause an implosion, whereas titanium, if it does have a little deformation, it will probably stay airtight and not implode. So this was a study done on the implosion of carbon or epoxy composite hollow cylinders. So the first study we looked at was metal, which isn't really related to the titanium. And then this one was actually done on carbon composite hollow cylinders. So they were laminated carbon epoxy composite tubes, and they were filament wound, which is the same as the Titan, so they're kind of related. And then the filament wound tubes also were 7 layers of unidirectional carbon, but they were placed in different angles, so this actually would have been stronger than the Titan. And then the unsupported length in the experiment was 280 millimeters, and then they studied 2 diameters, and I'm only focusing on the 76.21 because it gives a more similar length over diameter ratio as the Titan. So this was the experimental setup. You can see it's pretty similar to the other tests that I talked about, where it was conducted in a large spherical pressure vessel, and then the maximum pressure rating was 6.89 MPa. And then they flooded the vessel with water to get the best optical clarity they could, and then they filled nitrogen gas to pressurize it, and then it was increased gradually at 0.083 megapascals per minute until the specimen collapsed. So this was what they did the test on. They had a speckle pattern on a cylinder, and then they were painted with at least a diameter of 2 millimeters, so that each mark is 3 by 3 pixels in the recorded images. So then these were the results of the experiment under the pressure. So in the experiment, they found that the shorter L over D were a lot stronger, obviously, because they have a much smaller unsupported length. And then just going through the testing here, at time B, you can see cavitation begin and a longitudinal crack is about to start. And then after this, once the crack began, there was an abrupt drop in the local pressure inside the thing because obviously it was breached. And then it caused an increased acceleration because of the structural instability. And then at time C, you can see that this was the minimal pressure that the specimen ever received, and there was even more cavitation coming, and an increase in velocity magnitude and sudden loss of pressure, and created more longitudinal cracks. You can see in E, it's actually starting to rip apart. And then the highest pressure spike was seen at time D in that picture, and it was relatively large, and that's not usually seen in implosion studies of metals or homogeneous materials, and that was something new that they found in the carbon fiber. And then if you look at the plot here, you can see 2 peaks at E and F, and those are similar to the peaks that you find in implosion studies, and that just means that's when the wall contacts the center of the structure, so that created those peaks. And then you can see this largest peak in G, and that's from the high magnitude pressure pulse that caused the final buckling, which you can kind of see in the picture in G. It's like the worst of all the pictures. So yeah, from the results, you can see that there was longitudinal cracks, and then which are shown in A, and then in the second picture in B, they used optical microscopy to show the cracks, and they're parallel with the fiber angle, which means that they were in regions of high tensile stress and propagated through the weak resin structure. And then C, it's a little bit hard to see, but where C is, there's the fractured fibers, and those fibers are very short and very small. So that just shows that it was a pretty brittle collapse, and there was very little fibers that pulled out. And then these are just different carbon fiber buckling modes. And then actually going back to the previous one. So I think the Titan actually failed in a manner similar to what this study was showing. So it most likely did implode like this study. And I think that was the main failure mode of the Titan, kind of the thing that made it go bad the fastest and the quickest. But then all the other things I'm going to talk about kind of just added to why the Titan was bad. So yeah, again, here's the just different carbon fiber buckling modes you can see. And yeah. And then another bad thing about carbon fibers is it can become delaminated. So in the left, you can see an ultrasonic C-scan inspection, and all the darker areas are delaminations in a thing, and you can't actually see these, so you would have no idea that this is happening. And then in the picture on the right, there you can see the delaminations kind of from a different angle, and you can see they're all occurring inside the carbon fiber, and you can't see them from the outside. So specifically for the Titan, there was found that it was a very porous carbon fiber, which is not good because there was obviously going to be some voids in manufacturing, but all the voids under the increased fatigue would slowly come together like the picture and create multi-site damage, which would just lead to the overall fatiguing of the Titan every time it makes a journey up and down. And then on the right picture, you can see this was the actual carbon fiber used in the Titan. And one of the engineers shined a flashlight on the back of it, and you can just see that there's very big voids in the carbon fiber. So now moving on to the viewport and why I think the viewport was not designed very well. So the viewport was 21 inches in diameter and 7 inches thick and had a diameter to thickness ratio of 3. And just to compare it to the Alvin, that has a diameter to thickness ratio of 1.43, so about half. And the engineers at OceanGate thought the acrylic would give a good warning if it was failing by doing crazing, which that would obviously not be enough of a warning for the submersible to come back up and resurface. And the window that they had was only certified to 1,300 meters, and the Titanic is at 3,800 meters. So that would obviously, it wasn't classed for the depth that this was going. And OceanGate also refused to pay the manufacturer to build a viewport that would meet the required depth. So that kind of just shows how they really didn't care about what they were designing. And then lastly, from initial journeys and experimental ones, there were deflections noted in the acrylic, and nothing was ever done about that. So just on a quick calculation of the force on the viewport, you could see that the force from row GH was over 1,923,000 pounds, or yeah. And then on the Alvin, if you do a similar calculation, there's only 1.2 million pounds. So 34% less force on the Alvin windows at this depth, which is a pretty big difference, and why the Alvin was able to survive and not the Titan, even though I don't think the viewport was the main thing that caused it to fail. If the hull hadn't failed, the viewport probably eventually would have. And then lastly, for the hull warnings, or not lastly, but number 3, the hull warning system was not very good. It was pretty much a system that they just depended on the audio noises and listening to the cracking to see when it was about to fail, which that would not be good. So they kind of advertised it of why it works as a real-time monitoring system, and it samples sound waves through the holes multiple times a second. So they were just saying that's even better than having an actual strong hole, which is obviously not good. And they were spinning it into a positive thing when talking to the press or potential customers. And then they thought they said that it provides accuracy in assessing the health of the hole, which maybe it will assess the health of the hole, but it will not be able to warn you before the implosion happens once there is an instability in the hole. And then they said they completed extensive testing that showed increased acoustic activity always occurs before the structural fails, but again, it will occur, but not, you can't sense it fast enough. And then they were just telling everyone that pretty much they would be able to resurface before any damage, which they were not able to do clearly. Because, and then real-time health monitoring, again, they were just talking about how good this real-time health monitoring is when it was really not that good, and they also patented the design to make it seem even more viable. So why that actually didn't work, they actually did no non-destructive testing on the hull, so they had no idea any of the existing flaws in the material. So even if it wasn't cracking, there was probably still existing things. And from other customers that went on the Titan before it completely imploded, they could hear the cracking of the hull as they went down. And then Lockridge was the engineer working on this, and he was told that no form of equipment existed to perform a test, so that's why they didn't test it, because there just wasn't enough equipment. So, but again, not testing it is not good. And then acoustic analysis just shows when something is about to break. It doesn't prevent the breakage or anything. So really, once you know it's about to break, that means like the kind of your destiny set and there's no way to resurface the Titan quick enough. And just there's data that shows implosions happened within a millisecond to nanosecond of structural instability. So you can kind of see in the video I played in the very beginning of this how fast the implosion actually would have happened. And yeah, that's pretty much why the acoustic sensors were not a good idea and should not have been their main way of detecting failure. And then lastly, the Titan was not a clean sheeted design. So it actually started, they were just iterating on an initial model, which wasn't even close to what they were trying to do. So in 1996, it started off with Antipodes, which OceanGate just bought from someone else. So they didn't actually make it. And they refit it to be a tourist submersible in 2009. Then after that, they iterated on that to create Lula, which was the first submersible actually made by OceanGate, and they collaborated with the University of Washington's Applied Physics Laboratory. And this was actually the first one they made, but it took inspiration from Antipodes. And then it was just pretty much, yeah, cosmetic and electrical refit of Antipodes, and the hull was shaped like a capsule pill. And then it had a large viewport at one end, which is covered by the blue cover in this picture. And this was only designed for a max depth of 500 meters. And then from the Lula, they made Cyclops 1, which you can see looks pretty similar to the Lula. And in this iteration, they got rid of the duplicate control systems, which I'm not sure why they thought that was a good idea, because it's always good to have redundancy. And then they fitted it to go run off a PlayStation 3 controller, so the pilots could be trained quicker. And then Cyclops 2 was the next image, or the next submersible that came after Cyclops 1, which again was just a refit with slight tweaks of Cyclops 1. So this is when he decided he wanted to reach the Titanic, and they kept most of the design elements of Cyclops 1. And as soon as they talked about taking this to the Titanic, the University of Washington cut their contract, even though it was only 1/5 completed, which is just a bad sign when someone's taking out all their funding and help. And then their control system, a hand controller talked to the Wi-Fi unit, and then the Wi-Fi unit talked to a black box, and then the black box controls the thrusters, and this was all ran on Bluetooth. So if there was any drop in signal, it would just stop working. And normally things are hardwired, so when signal drops out, control still works. So it would have been a better choice to do hardwiring of the system, and this was an unclassed submersible. And then the Cyclops 2 came into what we now know as the Titan, which is the vessel that imploded, which is very similar. It was pretty much just a cosmetic refit of the Cyclops 2. So pretty much in all these iterations, they took a submersible that was supposed to go only 500 meters and took it to go 8 times that much, which is probably one of the main reasons it failed, because this design was initially only supposed to be 500 meters, and you can just know it's not good to not clean sheeted design, as you can see from the Boeing disaster. So this was just not a good idea to not start from scratch and just iterate on other designs. And then there's just a few other factors I want to highlight, not like the main reasons of why it failed, but other bad design choices. You can see in the picture that the O-rings, they were not manufactured correctly, and they deviated from standard design parameters, and they had plunge holes in the ceiling faces, which wasn't good. The video game controller system was just not the best way to control it, especially since it was Bluetooth, and then none of the passengers had seatbelts or anything. So in the case of just a large movement, everyone could become disheveled and move around the Titan, and the operator could even lose the controller. So it just would have been better to add seatbelts. And then you can see kind of in this picture, there's a lot of cables on the Titan, and they were just unrestrained. So sharks could have eaten them, and they were snagging hazards. So something could have gone wrong with those cables, and typically they're more tucked in, so they're not just so loose. And then the flooring was made of flammable materials, and that released toxic fumes, and that was not disclosed to any of the passengers that went onto the submersible. So then, just to kind of tie it all together, after the debris was found, it kind of suggests similar ideas of what I just talked about of why the Titan failed. So the first piece of debris that was uncovered was the front of the Titan which you can see from the picture, the viewport is missing. So that does indicate that that failed, but it probably failed due to the original implosion of the hull and not that failing first. But the viewport was not classed to be that low, so it probably did obviously fail. And then that indicates that the connection between the body and the viewport failed because there's no viewport. And then another debris they found was the titanium rings. So clearly, since those were able to be uncovered and they are not broken or anything, that means the titanium rings did not fail, and titanium is a better material to make a submersible out of. So that means maybe they should have made the entire thing out of titanium. And the carbon fiber, you can't see in this picture, but there was no carbon fiber attached to them, which indicates that there was just complete total failure of the adhesive, and that's why none of it is still stuck onto the rings. And then more debris that was found, there was also no carbon fiber attached to any parts of the vessel. So that just indicates that that was most likely the first thing that went out, and the hole that was pretty much a catastrophic failure of the hull. And there were some other parts of the vessel, but no carbon fiber uncovered. So in order to correct this, there's a few things that I would do. I personally think that they shouldn't have used any of the things that they did in this. They shouldn't have done a cylindrical one because the spherical shape is much, much stronger. They did a cylindrical one because they wanted to fit more passengers, but that wasn't really the correct choice, and they shouldn't have done that. They also should have used titanium because that's proven to work, and even if they didn't want to do testing, it would be a lot easier to test the titanium, and they could back it up with other successful submersibles. And then I would have used some adhesive and bolted attachments for the rings and holes. So if the adhesive failed, then the bolts would have been fine. And again, it's just good to add redundancies in a design. And then obviously more testing. They didn't test at all. They didn't do any non-destructive testing. They should have done that to see if just kind of the existing irregularities in the hole before sending people down in it. There was a lot of criticisms from other engineers, and they didn't listen. They just kept being confident in their design and didn't take into account any of the opinions of other people and other specialists in this field. So it would have been good to listen to the critiques of others, because that could have prevented this whole thing. And then if they wanted to keep the acoustic monitoring system, they should have added an additional warning system, even though a warning system may not have even worked at all. They probably just should have checked the material before each one to make sure it was good to go. And then they should have clean sheeted the design and added backups and redundancy in case of failure. So asking questions like, what if the main power sources fail? What if my computer crashes and the pilot loses control? What if my communication system fails? How can the submersible signal that there's a problem? Like, they didn't really think about answers to any of these questions, and they should have just had redundancies in the system that made sure it wouldn't fail. And then there would have been no lives lost. So just from this, there's a lot of ethics that were kind of not really good ethics in this project, and there was a fallout, obviously. So I just want to start with this quote by Stockton Rush, the owner of OceanGate. He said, "You are remembered for the rules you break, and I've broken some rules to make this. Carbon fiber and titanium, there's a rule you don't do that. Well, I did." So clearly he knew he was breaking rules, and he just continued to do them, to break the rules. So just in terms of ethics, Stockton Rush was warned by many other scientists and engineers not to continue. A lot of people sent letters to the government, tried to stop him in any way they could, and he just did not listen. He specifically structured this project to be out of U.S. jurisdiction, because in the U.S. you're not allowed to go in an unclassed sub, but then he said that the idea was developed and assembled in Washington, but it was actually owned in the Bahamas, and it was registered in the Bahamas. And since it only operated in territorial waters outside of the U.S., the classification rule that your sub had to be classed didn't apply to him. And yeah, and under U.S. regulations of submersibles, it's like really bad if you kill a passenger on it, but if you kill a crew member on it, it's not as much of a bad thing. So pretty much he classified everyone that went on the submersible as a mission specialist and not a passenger, so that if someone did die, it wouldn't be as much of a legal issue for him. It would have been more of like not as bad because of the US laws, obviously. And then and no one also bought tickets. They contributed their own money to fund their own missions. So pretty much that took a lot of the blame off of Rush if anything bad happened, because it was them funding their own mission. And they just prioritized money over safety, since this is obviously a business and it was just a money-making operation. So there's like a lot of financial pressure to continue doing the trips, whereas on a scientific vessel, like if there's something bad, they can postpone it because it's not necessarily, you're not going to lose customers, lose money, things like that. And then he also made a lot of false claims about the testing and the partnerships he did. So he said he was doing testing partnerships with Boeing and NASA, and that one iteration of the Hill would be built at Marshall Space Flight Center, and that just none of those things was true. So he lied about that when he said that. And then the whole electrical system was designed by interns that he was at one point paying $15 an hour. So it definitely should have been designed by someone more senior that knew a little bit more about just electrical systems in general, or at least just had one senior engineer on the project of the electrical system. And there was instances where we could tell that he wasn't always fully in control of the submersible. In one of his previous journeys, they were trying to resurface, but there was a malfunction in the system that caused the weights not to drop, and they will automatically dissolve in seawater after 24 hours, but he couldn't get them to physically remove, so they kind of just had to wait, but then he eventually got them off. And then another, in a different trip, this was one Rush wasn't actually down in the submersible with, one of the thrusters was installed in the wrong direction. So once they got to the bottom of the ocean, all they could do was go in a circle. And that obviously, when the thruster's in the wrong direction, that's pretty catastrophic. So they just had to resurface and drop the weights in that case. And then he just knowingly had features that were not tested or allowed, and he wasn't hiding this at all. He often did say out loud that he knew that he was doing things that weren't technically allowed and things like that. So he clearly just had no regards for the laws or doing what he shouldn't have done. And then passengers signed a very hefty waiver in order to enter, and they were not really told the full extent of all the illegal designs or anything. The main clause was, this experimental vessel has not been approved or certified by any regulatory body and could result in physical injury, emotional trauma, or death. And pretty much every passenger on this signed their rights away to this. And then after he fired his previous head pilot of this, he didn't have anyone to replace him, so he offered his director of finance and administration to be the head pilot, and obviously she felt really uncomfortable with this and ended up leaving the company. So then I would say the biggest breach of ethics was in the Lockridge lawsuit that happened for the Titan. So David Lockridge was one of the engineers, and he wrote up an inspection report detailing pretty much 25 issues he found about the submersible and was urging Rush to not put people in it. And after he came with this report to Rush, he was immediately fired and given 10 minutes to leave the premises. So obviously that was wrongful termination. So Lockridge contacted the Occupational Safety and Health Administration, OSHA, about a wrongful termination, and his investigator contacted OceanGate and said that they were investigating the firing of him in a whistleblower situation. So they then OceanGate responded with that, and they threatened him to drop the lawsuit, and pretty much they said that if he didn't drop it, they would sue him, destroy his professional reputation, and accuse him of immigration fraud. And Lockridge did not drop the report, so he went to court with them. And then the OceanGate lawyer also even said that Lockridge said or orchestrated his own firing because he wanted unemployment benefits. So in order to, what OceanGate was asking for was their settlement included resolving all the claims against OceanGate, withdrawing the OSHA claim, and paying $10,000 in legal fees and signing a non-disclosure agreement. And Lockridge did not end up agreeing to the settlement, and they followed through with the lawsuit that I was talking about in June of 2018, and then Lockridge fired a countersuit in August of 2018, And then in November 2018, they settled it out of court. So no one knows what came from this and what the specific details of the settlement were. So from all this, the fallout of just the submersible imploding, there hasn't been an official failure and report released yet because it only happened less than a year ago and no one's sure when exactly that's going to come out, but it was expected to take a few years or at least over a year. And then the investigation's being led by the US Coast Guard, and this was the first and only manned submersible implosion. And since the industry is so small, a lot of people in that field were worried that this would have bad effects for the industry as a whole because people wouldn't trust it as much anymore. And then I think that from this disaster, there's going to be a possibility to have new deep sea regulations and just more strict laws so something like this can't happen again. And it could possibly sway other countries to make more strict laws too. So you can't just leave the jurisdiction of your country to go do it in a more easy jurisdiction. And then it's also going to be very difficult for the families to sue OceanGate because of the waiver that they signed. So far, there's been no instances of anyone trying to sue them, but we guess you just have to wait and see. And then the Bahamas is a business-friendly jurisdiction. So if people were to sue, it would still be hard to win because kind of the Bahamas laws favor the businesses over the people. And then in June 21 of 2023, OceanGate's Everett office was closed indefinitely, so pretty shortly after the implosion. And then on July 6th, all operations are suspended. And then if you try to go visit the OceanGate website now, it just comes up with a black screen and says all OceanGate operations have been suspended. And then in August of 2023, Gordon Gardiner took over as CEO until the company shut down and goes out of business. So just in terms of who was at fault in this, I think it was the Stockton Rush, the CEO of the company, because he had many warnings and his engineers telling him this wasn't a good idea. And he just didn't listen. And ultimately, it ended up costing his own life and the life of 4 other innocent people, which just isn't okay. And I don't really agree with the other families of those that died not being able to sue because of the waiver, because I think they should have that right since there was just so many problems with this Titan. And then I don't really agree with the fact that nothing's happening, and it'll just be interesting to see as time goes on and the official failure report happens to see if there's any other updates with this. So yeah, that was all about the Titan submersible and why it failed. And obviously the carbon fiber hull was just not a good idea, and that was its main cause of failure. I hope you enjoyed this presentation, and here are my references. Yeah, thank you.